The question says, determine an expression to its simplest form for the frequency n of a simple pendulum. The frequency n depends upon the mass of the bulb of a pendulum, the length of the pendulum, and the acceleration due to gravity at the place where the pendulum is suspended. All right, so this one we've been told to say we're trying to look for the frequency of a pendulum. Then I'm also going to add k there to represent any constant in case there is n. Yeah, so we have k, and then they're saying it depends on what? On the mass. So I'm going to write the mass there. It depends on the mass. It also depends on the length. It also depends on the length and also the acceleration due to gravity. But I'm going to give them x, y, and z as the powers there because we don't know the powers they are raised to. So the frequency there, remember I told you to say the dimensions for frequency is simply just t to the power -1. So we can also write this as m to the power 0, L to the power 0, T to the power -1. So we are going to write that here. So we have M to the power 0, L to the power 0, and T to the power -1. So say this is equal to, so I'm putting this in square brackets. This is equal to K, open brackets. We have M, X, and then we have L, Y. Then the dimensions for gravity is simply just, so gravity is meters per second squared. So this is just the same as in dimension analysis, we represent meters as the length, and then per second is simply just, per second squared is simply just t to the power -2. So this is what we have. So we have that, which is L t to the power -2. Then we have z there. So we can rewrite this as m0, L0, t -1. And we say this is equal to k. Then we have m, x, we have L, y, we have, when you distribute the z there, we're going to have L to the power z and t to the power -2z. Oh, sorry, 2z. Okay. This is what we're going to have. So we compare the powers. So the power for m this side is 0. The power for m here we have x. And then, yeah, so we have x there. So we have x is equal to 0. That's the only m that we have this side. Then we move on to the powers for L. So the power for L is 0. Inside the power of L, we have y. Then we have also z plus z. So if you are multiplying two numbers with the same base, you always add the power. This is the principle that we're using here. So look at the powers of t. The power of t there we have -1. This other side, the power of t is equal to -2z. So already we have the value of x, which is 0. So to find the value of z, or z and y, we can also get this other equation, which only consists of one variable, which is z. So z will therefore be equal to, when you divide by 2 on both sides in this equation, when you divide -2 and -2 this side, you're going to get your z as 1/2. And then we can also find y from this equation because we know that z plus y is equal to 0. So our z is therefore going to be equal to -y. We're looking for y, so let's make y the subject. So this is going to be y is equal to -z. So z is half, so the value of y becomes -half. So we can write our formula. So the formula for frequency will therefore be equal to k, and then m, the value of m there, I mean the power of m is what? Is 0. and then is x, which is 0 in this case. Then the power of L is what? Is y, which is negative half. Then the power of G is half, which is which is 1/2. Okay, so we can just rewrite the formula properly. So we have n is equal to k, and then this power, so we have g to the power half, and because of this negative on the L, can take it down, so we have L to the power half as well. So this can also be written as k, then open brackets, g over L to the power half. Then anything raised to the power half is just the same as the square root. So we have k root g over L. So this is the formula for the frequency of a pendulum. If you remember, there was a question where we had this question. We had this formula. Yeah. All right, so we move on to the next one.